With the DS6000, what I'd like to show is also the reference waveform. So we can pull up the reference menu here with the reference key. You'll see now there's a white dotted line. That's one that had been saved earlier. With the references, we can save up to 10. You can see that internally, and then we can also save externally via the USB. So let's save this for reference channel 1. Oops, I'm sorry. A little overzealous with my pressing. And then let's do a save, and you'll see now, if we move channel 1, that we've saved that reference waveform. And reference waveforms can be very useful if you want to maneuver or manipulate a waveform and check it versus an original waveform, just visually be able to take a closer look at how things are going with a particular waveform as you go through. And again, if you want to disable reference waveform, you can just double press the key, and the reference waveform will then disappear. And now with the DS6000, what I'd like to do is take a closer look at some of the math functions that we have available. I'll slide out the math menu, and we can start describing some of these. Very common to most scopes, we have A plus B, A minus B, A times B, A divided by a B. We also have an FFT function. Let's cover that. And with the FFT, we're actually taking the time domain signal up above, and we're processing it and pulling it back into the frequency domain. You'll see now we have a split screen, which we can go from a split screen to a full screen if you'd like, and we can then manipulate the position of the FFT on the full screen, or we can go back to split screen. Personally, I like to have a split screen because they really are just different scales. But I'm just going to move the vertical position of the math function down here, and you'll see that we have a number of peaks available to us. If you remember back to your FFT, for a square wave, the frequencies are going to be you're going to have a primary or a fundamental frequency, and then you're going to have all of the odd harmonics. And so with this, with the DS6000, you can see we're reading off of the center frequency here. That's at 17K. What we can do is horizontally we'll move the fundamental frequency, which is our highest peak here. Move that down just a touch so we can see it all. So our fundamental is at 1K, which makes sense because our probe compensation point is 1 kilohertz square wave. So our primary is at 1K, our next peak is going to be at 3K, our next peak is going to be at 5K, and so on and so forth as we go down. So you can see we have all of the odd harmonics, so everything makes sense in that particular regard, which is good. Now I'm going to go cover some of the others. Let's go to advanced, because I think that's where we get some of the processing power really shows here with the DS6000. If we pull up advanced, what we get is we have an expression that we can create. And it's not just A plus B and A minus B. You can actually see we can select channels, and then we can also select the actual operators that we're going to be using. And so if we want to select particular areas that we can work on, we can do integrals, we can do differentials, logs, exponentials, square root, sine, cosine, tangent. You can create your own variables. Some of the operators that we have available are plus, minus, multiply, divide, less than or equal to, and also some logic operators. So some pretty powerful mathematics that are capable, or that the scope is capable of doing and performing on that incoming wave function. And also it can bring in multiple channels as well. So I'm going to disable channel 2 just for clarity here, make the display a little bit more clear. Bring that down. Oops, we'll just center it. That'll be fine. And then we'll, with the record features, what I'm doing, I'm just centering that signal. Now what we're going to do is I'm going to show you the record features, and then we're going to go through the pass-fail analysis function of the record. So to get to record, we're going to press Utility, open up the record menu, and then let's enable record. And you'll see that now we have 3,986 end frames, or that is our end frame. You can basically think about a frame as a bitmap image of the displayed values on the screen, and the number of frames that we have is directly corresponding to how much data we're going to collect per frame. If you're going to have a very large data set per frame, we're going to have a limited number of frames. If you want to have more frames, you're going to want to collect less data. In order to access the data collection, most of the time the scope's going to be running in auto mode, but if you press the acquire key, you can go to the memory depth. Again, most of the time the scope's going to be set in auto. And in auto, it's going to automatically decide what is the best sample rate as well as the best number of data points to take for that particular horizontal time frame. Right now we're on the 100 microseconds per division time scale, and we're collecting 5 gigasamples per second rate at 7 million samples, or 7 million points. If we go down to the 1 millisecond per time division, now we've gone up to 70 million points. And you can see now we're at 140 million on the 5 milliseconds, etc. So in auto, it's going to automatically select the number of data points that are going to be collected. But we can also force the scope into a manual mode. So let's say, let's collect 14,000 points per waveform. Actually, yes, let's do that. And then if we go back over to record, we can see now we have 3,000 frames that we can collect. And very straightforward, we can set the interval, which is the time between frames. So if you want to have a large time delay between frames, let's say 1 second, you can very easily set that just by adjusting the knob here, or selecting that value and then adjusting the knob. So we can go all the way up to, I believe it's tens of seconds if you wanted to do that between frames. Typically you're going to want to have that recording be as quick as possible because you want to basically create this giant movie of all of these different frames of data. To record, very straightforward, we can either press the operate key here, and you'll see we'll start to collect. We can also stop it, or even better, we can actually use the record, stop buttons on the in this ultravision area. So you see we've collected 280 waveform recordings, and now what we can also do is we can actually analyze that data. Actually, I'm going to record some failures, so we're going to go back to recording. And now I'm going to select channel 1, and I'm going to just pull it off the probe compensation point, and you can see now we're getting some different values here. And then I'll place it back on, and now I'll stop. So we've collected 1,890 frames. Now let's go to Analyze. And in Analysis, you'll see now we have a split screen. On the top screen, we have a picture of the first frame of a waveform, or the first waveform that we've collected in memory. And we can select any number of those by using either the outer ultravision knob, which is going to give us a fast forward effect. You can see that we're zipping along now, we're at 1,890 frames, or we can do one at a time using the inner knob, where we go 5, 6, 7, 8, and back again. So the idea is, what we can do is select a waveform that we consider an ideal waveform, or a golden waveform, and then we can actually set up, analyze, we can do a trace, or we can do pass-fail. And I'd like to take a closer look at the pass-fail. Pass-fail, it records, or we can set up a mask around that waveform that we have displayed based on the number or a percentage of the divisions that we have. In this case, we have 0.24% or 24% of the division for X and 38% as Y. We hit create mask, and you'll see now all of a sudden we get this framework around that golden waveform that we've decided is a good waveform. And now we can analyze, go to the second page and press start, and it will analyze all of the other waveforms versus that golden mask. I'll just let it run for a second. And we're at 1145, 1890, and now it's actually playing through all of those waveforms. And it says analysis is finished, press run stop single to view. Now you can see we're at frame 799. I'll explain a little bit further. This is actually the first error frame. You can see that based on our mask, we have quite a bit of area quite a bit of the waveform that's analyzed outside of that waveform. And you can see now on this bottom line, this is the entire waveform recorded memory, and the red denotes areas that have failed, and the blue denotes frames that are good. The upper is this center area is a zoom into the different frames that we have failed, and then on the left-hand side it tells us how many error frames we have. So this is 344 out of the total, which was 1,890. And you can very easily go using previous or next. You can go to each of the failed waveforms. And so you can actually cycle through each and every failed waveform, or again, you can use the fast forward key. Again, we're sliding along very quickly through that entire waveform, or you can go one frame at a time by using the inner the inner knob like that. Very fast and easy way to analyze a standard waveform in order to collect data over a particular period of time. You could take a look at, let's say, if you had things happening over a period of minutes or hours, you would be able to analyze that waveform and go, oh, okay, if you know the time scale, you can figure out the time for each frame and have a very good understanding of when certain things dropped out. If a power supply came online or something and it pulled the signal that you're looking at low, it can be an extremely powerful way to analyze data and serial data as well. For slower moving signals, the DS6000 also has a roll mode. What I have here is a function generator off to the left that's set up to perform a waveform that's sort of like a cardiac or EKG signal, and I have it set to do a 100 millihertz signal, and right now we're triggering on it, but you can't really see a whole lot of detail. What we can do is enable roll mode, which is in the horizontal timescale, horizontal menu. Again, horizontal menu, and we can select roll, and now what we're getting is a rolling trigger, and the display is then updating automatically from right to left. So it's not acquiring data and then displaying the data, it's more of an active acquire display for each of the data points, and you can see it's rolling right along. You can also decrease the roll rate, much like an EKG machine in a hospital. And so if we had a time-varying signal that was very long, let's say below 10 hertz or so, this is another way of displaying the data, and it will actively show you what's happening, but in a continually updated fashion. It can be useful for slower signals.